So energy, work and power. Work done is product of power and time. So power is equals to work done over time, and energy is mgh, which is potential energy. Energy is half mv square, which is kinetic energy. And in both the cases, if we have to find power, what we do is just divide it with time. What we do is divide half mv square by time. And where is that useful? For example, we have a question that a motor is pulling a weight upwards, so that is gain in potential energy, and you are given with the time, so you divide the work done by time, you get the power of the motor. Kinetic energy, again, if there is change in speed, if the object was suppose moving at 2 meters per second, so you apply half mv square, and then the object gained a speed of, let's say, let's consider it horizontal, and it gained a speed of 7 meters per second. So again half mv square, and the change in kinetic energy is due to some force applied to it or the engine. So change in kinetic energy divided by time again gives you the power. Let's have a look at the questions. And before we do that, some examples. Conversion of energy from potential to kinetic, kinetic to potential, and back. For example, we are considering an object which is falling from an height. So at height it has potential energy. When it falls down, it changes into kinetic energy, and in between, that is a sum of potential and kinetic all the way. Potential is dropping and kinetic is increasing before it hits. And for any object we can apply this formula, that potential energy plus kinetic energy plus work in is equal to potential energy plus kinetic energy plus work out. And this is basically the initial kinetic, initial potential, and work in is work done against work done by the applied force, and potential energy final, kinetic energy final, and work out is work done against any resistive forces or friction or gravity. For example, in this case, if I say that it was at a height of 10 meters, the mass was 2 kgs. So basically the potential energy right here is initial potential energy, which is mgh, which would be m into g into h. And kinetic energy at this point, we know that it is being released from rest is 0. Work in, there's no engine on this ball, so it is again 0. On the other side, we know that potential energy final, when it reaches the ground, mass, gravity, but height is 0, and kinetic energy would be half mass is 2, velocity v square. Work out is against resistive forces, so if it is falling through the air, and if it is given that there is no resistance, and we can say that is again 0. If there would have been any, it would be given in the question. So we just plug in it the equation, and we get left hand side equal right hand side, and we can find the final kinetic energy, which is obviously in this case equal to potential energy. Second part of the question would be find the speed before which the particle hits the ground. So we do have the energy, and the equation half mv square is equals to potential energy, which was converted into kinetic. So v square is equals to 200, and velocity would be square root of 200, which is around 14 something, 14 meters per second. So let's have a look at the first question. Question number 34. A car of mass 1000 kgs is moving along a straight horizontal road against resistances of total magnitude 300. So car mass 1000 kg and constant resistive force of 300 newtons. Find in kilowatt the rate at which the engine of the car is working when the car has a constant speed of 40. So power is equals to force into velocity. Force is given, that is 300. And why are we taking this? This force is actually the driving force. But if it is moving with constant velocity, that means forward force is equal to backward force. So which is 300 times 40 is 12,000 watt. And in kilowatt it is 12. Second part says find the acceleration of the car when its speed is 25 meters per second and the engine is working at 90% of the power found in part 1. So 90% new power would be 12 into 0.9. So we have the new power which is 10.8 and we have the new speed. So power is equals to force into velocity. Sorry, we already have the power. And the demand of question is acceleration of the car when speed is this. So F equals ma. Mass is 1000. Acceleration is unknown. And at that time, force. So power is equals to force into velocity, where F is the driving force and 108 and divided by velocity is 25. 108, that was kilowatt. So times 1000, 10800. 10800 divided by 25. Driving force at that time is 432. So we plug it in the formula. F net is equals to mass into acceleration. F net is forward force minus the resistive force by 1000 is equals to acceleration by 1000. So acceleration is 0.132 meters per second square.